Okay, the last section that we'll cover in chapter 3 is 3.4. The last section that we've been doing with all the worksheets have been part of section 3.1, just so you know. In 3.4, we're going to talk about quadratic inequalities. A quadratic inequality is the same as an equation, only instead of an equal sign, we're going to have a less than, a greater than, or an equal to, a less than or equal to, or a greater than or equal to sign. So for example, suppose that we have x squared plus 4x greater than or equal to 5. Okay, so x squared plus 4x minus 5 greater than or equal to 0. And I'm going to set y to be equal to what I see on the left there, x squared plus 4x minus 5. And I'm going to set y to be equal to 0 temporarily. X squared plus 4x minus 5 equals 0 means that x plus 5 is 0, or x minus 1 is 0, is how that factors. So x is equal to negative 5 and x is equal to 1. Okay, these two numbers are called critical numbers, and that's not really any terminology that you have to know, but I would position the two critical numbers on a number line above the table. And this table you'll be making for every one of the quadratic inequalities except for a special case or two. So I want interval, number chosen, value of y, and then the conclusion. Okay, the interval will be the open intervals not containing the critical numbers. Okay, so the first one is negative infinity to negative 5. The middle one is negative 5 to 1. And the last one is 1 to infinity. Now the next thing I'm going to do is I'm going to select any number as long as it's in the interval. Okay, so negative 6 is in the first one, 0 is in the second one, and 2 is in the third one. And then I'm going to plug that value into the equation to find the corresponding value of y. So when x is negative 6, negative 6 squared is 36, minus 24 is 12, minus 5 is 7. 7 is a positive number. And my conclusion all I write is if the number is positive or negative. Okay, and then move on to the middle one here. If x is 0, y is negative 5. And that's a negative number. And when x is 2, 2 squared is 4, plus 8 is 12, plus 5 is, or minus 5 is 7. Okay, now the reason why I've got these two circled is because I've got an expression that is greater than or equal to 0. Numbers that are greater than 0 are positive numbers. Okay, so as long as x is negative 5 or less, or 1 or bigger, you're going to have a true statement when you plug that number into the formula. If x is between negative 5 and 1, then the statement is false. So like if x is 0, negative 5 is not greater than or equal to 0. Okay? So I disregard the negatives column there. The last thing I'm going to do is I'm going to take a second look back at the inequality and notice that I've got a less than or equal to, so I'm going to include equal to signs in my inequality. Even though I've got open intervals here, that's okay. I want open intervals everywhere in the table because you see I don't want to choose negative 5 or 1 as my critical values, and if I were using a bracket, that would mean that I'm including the numbers when in fact I shouldn't be. And so the number that's chosen could actually be negative 5 or 1. Negative 5 or 1 would return 0. Okay, so, and I don't want that because 0 is not positive or negative. Okay, so 0 tells me nothing. My answer would be negative infinity to negative 5 brackets, or brackets 1 to infinity. Okay, and here's how that looks on the number line. I've got that written in such a way so that it doesn't make any sense. Negative 5 is not bigger than 1. Of course, this is the way to write it. Set of all x such that x is less than or equal to -5 or x is greater than or equal to 1. Okay, another way to do this is to sketch a graph. If we let y equal f of x, y equal x squared plus 4x minus 5, then that's what we need to graph. Okay, first thing is that I know I'm graphing a parabola. This will always be a parabola. Okay, so keep that in mind. A is 1, okay, and so I know the parabola opens up. The vertex, negative b over 2a, well, negative b is -4, divided by 2a is 2. So -2, and when x is -2, -2 squared is 4, minus 8 is -4, minus 5 is -9. Okay, so here's -2, -9, which is the vertex, which is the lowest point on the parabola. The intercepts, we easily just set these equal to 0, and so x is equal to -5 and x is equal to 1 would be the x-intercepts. The y-intercepts, I've already found that. When x is 0, you get y equals -5. So here's 0 and -5 on the graph. Okay, and I've got some more points plotted because of symmetry. Now the next thing I'm going to do is I'm going to look at my answer and I'm going to say, where is the parabola positive? Where is the parabola greater than or equal to 0? Well, up above the x-axis is when y is greater than or equal to 0. When the parabola is on the x-axis, that's when y is equal to 0. When the parabola is below the x-axis, that's when y is negative. Okay, so y is greater than or equal to 0. So I need to know on this graph, where is the part going to be where I'm greater than or equal to 0? Okay, well, I'm, let's see, if I'm less than -5, or if I'm bigger than 1. I don't want -5 to 1, because that part is below the x-axis. So, and I got greater than or equal to, and so I would end up getting the same exact answer, the same thing. Now, I prefer that you use a table instead of using a graph. Okay, a graph can be helpful, but you're kind of limited with a graph because you're hoping that the x-intercepts don't involve are nice counting numbers like -5 and 1, and sometimes they're not. So I like the table method better. In calculus, you do a lot with tables, and so it's kind of a preview to things there if you're headed that direction. Okay. Second problem. 2x squared less than 5x minus 3. Well, the step one is always to get everything onto the left. 2x squared minus 5x minus 3 less than 0. Okay, so this is going to, if I call this y and set y equal to 0, and this is going to factor as 2x plus 1 times x minus 3 equals 0. And x is equal to -1/2 and x is equal to 3. Okay, so if I draw a number line above the table and position those two numbers, -1/2 and 3, then the intervals, -infinity to -1/2, or -1/2 to 3, or 3 to infinity would be written. Make sure that those are open intervals. Okay, the number chosen has to be in that interval. Probably the mistake that I'll see a student make the most is that a student will make a mistake where they'll be selecting a number that's actually not in the interval. Like here they'll be selecting -1. Okay, -1 is in this interval, not this one. Okay, so I choose a -1 and then 0 and then 4 for my three test values to plug in and find the corresponding value of y. Okay. When x is -1, I get 2 plus 3 is 5 plus 5 is a 7 minus 3 is 4. When x is 0, I get -3. When x is 4, I get 4 squared is 16 times 2 is 32 minus 20 is 12 minus 3 is 9. 9 is a positive number. Okay, so now I'm going to take a second look back at the inequality, and notice how I've got 2x squared minus 5x minus 3 less than 0. Less than 0. Okay, so I've got an expression less than 0, which means I've got a negative output. Okay, so I want the negative column to be in my answer. And the set of all x such that x is in between -1/2 and 3. Or I can use the interval. The interval will be preferred, by the way, since you're using interval notation in the table. And here's how that looks on the number line. Okay. One more example. If we want to solve 4x squared plus 9 less than 6x, let's get everything on the left. 4x squared minus 6x plus 9 less than 0. And I'm going to call that y and set y to be equal to 0. And just to play around with the factors here, if x is 2 and x is 2, and 2 and 2, well, if I use 1 and 9, that's not going to work, right? I'm not going to get -6x. 3 and 3, and that's a negative, so that's and the last term is a positive. So the only way for that to happen is if both the signs are negative signs. Okay, y equals 2x minus 3 times 2x minus 3. Well, I've got -6x minus 6x is -12x. That's not going to work. If I use 1 and 4, 1 and 4 and 9 and 1, that's not going to work. At 1 and 4 and 3 and 3, yeah, it's not going to work either. That'll give me -15x. So I'm just not seeing how this is factoring. Okay? Which means that my next best option is to use the quadratic formula. X is equal to the opposite of b, which is 6, plus or minus the square root of b squared, that's -6 squared is 36, minus 4 times a is 4, times c is 9. All over 2a, 2 times 4 is 8. 36 minus 108, or minus 144, is -108. Okay. Now, whenever you have the square root of a negative, there is no table that you're going to make. You're just going to simply select one test value. It can be any number you want, any number. I always take 0 in this case, just because 0 is the easiest to use. And then I plug 0 into the equation. If x is 0, then I get 9 less than 0. 9 is not less than 0. Okay, so there's going to be no solutions to that equation. Okay, now what if I have this exact same problem, only I switch the sign? Okay, well, I'd go through exactly the same procedure. I'd have exactly the same values of x. Okay, I'm not going to make a table, but I select a test value. Now this time if I select 0, then 9 is bigger than 0. That is true. 9 bigger than 0. And so my answer would be all real numbers. So whenever you have the square root of a negative, okay, there's not going to be any table that you're going to make. You're going to try a test number, say 0. 0 is the easiest, okay, and see if that number produces something that's false or something that's true. If the number produces something that's false, any number that you select is going to produce something that's false. If the number is true, any number that is going to be selected is going to produce something that's true. Okay, So no solutions is the answer there. Here's the homework for this section. Be sure to look at those when you get a chance. I know we went completely out of order there in chapter 3. We did 3-5 first, and then 3-2, and then 3-3, and then 3-2, and then 3-1, and then 3-4 is the last one that we did here. So I know that's kind of out of the normal plan there. The rest of the sections will be in the regular order that we see, by the way. Okay.